Hello, friends. So here is the T-test redo. So this is where the T stands for try again, Mr. Watka. The lecture today was a little bit foggy, as I could tell by many of your glazed over expressions. It's fine, I see you. Um, so I'm going to go over it again, and we're going to go from top to bottom. So the before we even get to a t-test, we have to know sort of what category of testing it falls under at all, right? And it falls under this heading of hypothesis testing. So how can we test the results of an experiment to see if we got meaningful results? So we can do lots of experiments and get results, but whether or not those results are due to what we did in the experiment, like what I showed you in class. So were those results in changes of lean muscle mass, did that happen because of the change in diet or because of some chance, right? And we want to take out as much of that, like, oh, it happened on a fluke. We want to take out as much of that as possible. And the t-test basically tells us maybe there's too much ambiguity. Maybe there's too much of the like, oh, some of the vegans got poisoned by tofu and we don't know if these results are valid, right? Maybe there's too much of that to say that the difference that we saw in our test was real, right? It was actually caused by what we were testing, the food, and not something else. Okay, so you are essentially figuring out the odds that whatever you tested just happened by chance. That's what you're doing in a hypothesis test. We want to see that your chances that the probability that this happened just like at random um, is less than 5%, right? And then we're saying like, all right, 95% confidence level, I trust you. I'm willing to take that bet. Okay. If there is more than a 5% chance that this happened because of like the whatever variations in the data or just some sort of fluke, it's not going to be repeatable, right? You won't get those same results if you do the test again and again and again, because it happened by chance. It happened by some weird fluke, right? Where like, of course, the muscle mass cohort eating meat didn't gain as much mass as we thought they would. They all got the stomach flu, right? Things like that. And moving on. Okay. This is fun. So whenever you test a hypothesis, you're testing the null hypothesis. The null hypothesis is like the nope hypothesis. It's the naysaying hypothesis. So basically, it's that kid who, when you're like, oh, I think I could do like 20 jumping jacks in a row, and they're like, no, you can't. No, 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 right? This is like when my little one, Eloise, is like, I bet I could stick 4 muffins in my mouth and eat them all and chew them all at the same time and it'll be delicious. And my older one is like, no, you can't. No, right? You're testing her. You're testing Eloise. You're doing a t-test, okay? You're testing her against the null hypothesis and she's saying, I'm going to prove it to you, right? T-test is doing the same thing, right? Um, I think that eating a vegan diet is going to make you gain more muscle mass. No, it's not. Who's that? That's the null hypothesis coming in to be a naysayer, right? So you need to take your data, do a t-test, and the t-test is going to say whether or not your null hypothesis naysayer is right or wrong. Okay, so that was rambling. A hypothesis. Athletes who consume a plant-based diet will increase their lean body mass percent by a greater percentage than the meat-eating cohort after 90 days. That's what we talked about in class, where we've got like meat eaters versus vegans doing P90X. Okay, fun program. Null hypothesis. This is what happens. That, like I just said, is saying that the researcher's wrong. It's always going to say the opposite of the hypothesis. Null. Look, there he is again, right? This is another way that we look at the null hypothesis, which just says that there is no significant difference, right? The null hypothesis is saying that the hypothesis is wrong, and the null hypothesis is saying, going even a little bit further and saying like, not only is there not the difference that you think there is, Mr. Hypothesis, but there's actually no difference at all, right? Null hypothesis. Okay. What you also want to know is To accept the null hypothesis means that you have accepted that your data is not significant. It didn't make the cut, right? So you're accepting the null hypothesis. You're saying yes, naysaying null hypothesis, you are correct. And there was actually no significance to my data. It could have been caused by chance. Um, if you reject the null hypothesis, on the other hand, you reject that naysayer and you say, carry on with the testing, there actually is a significant difference that was made evident in the results of my test. I can eat all of the muffins. Okay, so the point of a t-test. You are comparing the averages of two sets of data. And it tells you if there's a difference between those two sets of data, and it tells you how significant that difference is. So if you see a small difference, the t-test is going to tell you that small difference means something, or that small difference probably wasn't caused by what you think it was caused by, right? So like that small difference in muscle mass gain wasn't caused by a vegan diet. It was caused by the fact that you compared males and females, right? And having testosterone makes you gain muscle mass at a much faster rate. Okay, so the t-test is also going to tell you if your data is good enough to reject or accept the null hypothesis. If your data is good, you can reject the null hypothesis, right? If your data is not so good and there are too many flaws in your data and you can't be sure that your experimental design is really what caused the changes that you see in your results, then you have to accept the null hypothesis and start from scratch. Sad times, but such is the life of a scientist. So essentially, the t-test is designed to tell you the real difference between the two groups that you just tested. Very, very exciting. These are examples. So drug company wants to test a new cancer drug to find out if it improves life expectancy. In an experiment, there's a control group. So there's a group of people who didn't get any of the cancer treatment. There's another group that did get the cancer treatment. You didn't get the cancer treatment, life expectancy 5 years, you do get the treatment 6 years. So the t-test is kind of saying like, okay, yeah, this difference might be due to the drug, but we're going to need to take a look at the statistics and find out whether or not that 1 year extra on the life expectancy is in fact due to the drug and it's not due to something else, right? Like maybe it's due to the fact that the people in that test who were taking the medication also had a healthier diet, right? Or it participated in exercise more often, right? It can't be due to some other weird factor going on. All right, so here is another example that I'm going to let you read, mostly because it's 10 o'clock at night. It's way past my bedtime, and I'm going to start rambling. And that's the next one, is the prequel to the t-test. Now, try not to get too excited. I know it's going to be a good one. Maybe you want to take this time to make some popcorn or something like that, because Ttest keep going forever. They never die. It's like zombies. Keep coming back.